Okay, welcome to video 12.1. In this one, we're going to be talking about analyzing statistic diagrams. So we're going to start with univariate statistics, and this is the collection, organization, analysis / interpretation of data that has one variable. Usually, numerical data is what's being collected, and we have quantitative data, which is numerical data on a single variable is often collected in order to understand how a characteristic of a group differs amongst the group members or between groups. So we will have a couple of statistical measures we're going to look at. One is the mean of the data, and you've probably heard this before. This is the average of the data, and it's found by dividing the sum by the number of data values. The median of the data, probably something else you are familiar with, that's the middle data value when the data is in order from least to greatest. And we're going to talk more about when these are used and when one is better than the other later. So now we're going to look at analyzing univariate statistic diagrams. The first one we're going to talk about is dot plot diagrams. So if we look at this example here, Charlie's Food Factory currently employs 28 workers whose ages are shown below on a dot plot. Answer the following questions based on this plot. So the first question is, how many of the workers are 18 years old? And then we want to know what percentage of the workers are 18 years old. So first, let's figure out how many are 18. To do that, I need to look to find where 18 is. Since this is 15 to 20, I am counting by 1 there, so I need to go to 15, 16, 17, 18. So those are where all my 18-year-olds are. How many are there? Well, if we look above 18, I see 1, 2, 3, 4 dots. So that means 4 of the workers are 18 years old. The next question was, what percentage of the workers are 18 years old? Well, I need to figure out how many there are altogether. Now, of course, we could count them all up because that should represent all of the people working at Charlie's Food Factory, but I know from the part above that there were 28 workers. So I know that I can go ahead and just put the 28 as the total. So to find the percentage, I say how many are 18 years old, which is 4, out of the total, 28, and I get my decimal. But that's not a percent. So we already talked about how we can change percents into decimals. So now we're going to go the opposite direction. So since I'm trying to turn this into a percent, I'm going to move the decimal place 2 places to the right. And I'm just going to say to the nearest percent here, so about 14%. So I know 14% of the workers are 18 years old. B says, what is the worker's range of ages? Well, this comes up with another vocab word that we're going to be talking about, and it's a range. Now, we have talked about range in the past in relation to a graph. This is saying how much is it spread. So if I want to know the range of the data, I need to say how that one number to represent how much variation there is or what the range is. So to figure that out, I need to subtract the maximum minus the minimum. So the maximum age that I see is over here, which is 42 years old, and the minimum is 16. So my range is from 16 to 42, but I want to represent that as one number. So I do 42 minus 16, and my answer is 26. The next question is, would you consider this distribution symmetrical or skewed, and how can we tell? So these are 2 more vocab words that we will be talking about. Symmetrical or skewed. So if it's symmetrical, that means that, like you know from symmetry, it's about the same on each side. Skewed means more of the data is in one area and it tails off in another part of the graph. So if I look at mine, I can see that the bulk of data is over here. If you can kind of think of it as like a curve, this is all of my data and then it goes off to the right. So this tails off. So I'm going to say that the data is skewed to the right because the right is what messed up my data. There's all of this bulk of information. If the information to the right was not here, then it would be pretty symmetrical, especially if it was right in this area. But because of all this data to the right, it is skewed to the right. So I can say that the data is skewed because there is more data on the left side and it tails off to the right. Therefore, the data is skewed right. The last part says that the mean age for a worker is 22. Why is this value not representative of a typical worker? Well, if we look, there's really only one person that's 22. The higher data skewed it, so that messed with the mean. So I just wrote the mean is not representative of the typical worker because the data is skewed, so the median is a better representation of the majority of the data. And we'll talk about this more in class. Have a good night.